In this video, we will discuss about the electrodes. Electrodes. Electrodes are employed to pick up the electrical signals of the body. In presenting the bioelectric event to the pre-amplifier of signal processing circuit, a pair of electrodes plays a role of a transducer. Since the electrodes are transferring the bioelectric event to the input of the amplifier, the amplifier should be designed such that it accommodates the characteristics of electrodes. The type of the electrode to be used depends upon the anatomical location of bioelectric event and the dimensions of the bioelectric generator. The electrical characteristics of the electrodes specify the type of the pre-amplifier. When the microelectrodes are employed, then there are so many restrictions on the input impedance of the amplifier. Since they have large impedances, high resistance, and low capacitance, input circuits are needed to transfer the bioelectric event to the amplifying system. Off-cell potential or electrode potential. The voltage developed at an electrode-electrolyte interface is designated as the off-cell potential or electrode potential. In the case of a metal solution interface, an electrode potential results from the difference in rates between two opposing processes. First one is the passage of ions from the metal into the solution. Second one is the combination of metallic ions in solution with electrons in the metal to form atoms of the metal. So, when a metal electrode comes into contact with an electrolyte, that is the body fluid, there is a tendency for the electrode to discharge ions into solution and for ions in the electrolyte to combine with the electrode. The net result is the creation of a charge gradient. This is called electrical double layer. Then perfectly polarized electrodes. The electrodes in which no net transfer of charge occurs across the metal electrolyte interface. Perfectly non-polarizable electrodes. The electrodes in which unhindered exchange of charge is possible across the metal electrolyte interface. Figure shows the electrical equivalent circuit of a surface electrode when it is in contact with the body surface. The electrode-electrolyte interface resembles a voltage source having off-cell potential EHC, which is developed due to charge gradient, and a capacitor CD in parallel with a leakage resistance RD. The series resistance in the equivalent circuit RS represents the series electrolyte and skin resistance under equilibrium conditions. Nernst equation. The value of the voltage and impedance depend on the electrode metal, its area, the electrolyte charge density, and frequency of current. The off-cell potential or electrode potential is measured with reference to hydrogen electrode placed in the electrolyte near that metallic electrode. The off-cell potential developed can be expressed by the Nernst equation. EHC is equal to minus RT by NF ln C1 by C2 into F1 by F2, where R is the gas constant, T is the absolute temperature in Kelvin, N is the valence of the electrode material, F the Faraday constant, C1, C2 concentration of ion on either side of the membrane, F1, F2 activity coefficients of the ion on the two sides of the membrane. In dilute solution, F1 is equal to F2, that is equal to 1.